All right, this video, we're going to integrate x times arcsine of x squared dx. The first thing that we're going to do is a u-substitution. And instead of u, I'm going to use t equal to x squared. The next thing that we want to do is take dt. And for that, we're going to take the derivative of x squared. And for that, we'll get 2x times dx. Next, we're going to substitute those two things into our original integral. So this is going to be the integral of x times arcsine of t now, because if you see here, t is equal to x squared. So instead of x squared, we're plugging in t. And then here we have dx, but instead of dx, we're going to solve this, this part of our u-substitution for dx and then substitute that instead. So on this one, to get dx by itself, we divide by 2x and we get dx is equal to dt over 2x, and we're going to substitute that instead. So hopefully you can see we have now this right here, we're going to put that in place of dx instead. So what that looks like is times dt over 2x. Okay, here we have a little bit of a problem because we want to take the integral according to dt, but we still have a couple of x's there. But notice here, this x is on the bottom, this x is in the numerator, so those actually cancel out. So we only have t's left. If you're doing u-sub and that does not cancel out, and you're in just single variable calculus, then you might have an issue there. All right, so if I cancel those out, I'm also going to pull out this over 2 part. So if I have that over 2 part, it's really a 1/2. And then I'm just going to rewrite arcsine of t dt. Okay, so that was the big first step, would be a u-sub. The next step is integration by parts. So now I'm looking at the integral of arcsine of t dt, and we're going to do integration by parts for this one. The formula for integration by parts is the integral of u dv is equal to uv minus the integral of v du. So the reason why I didn't choose u when I did u-sub is that I knew I would be using a u here and I didn't want to confuse myself. Okay, so the first thing I need to do is choose my u, and I'm given arcsine of t dt, so I'm going to make u equal to arcsine of t. That would make my du equal to the derivative of arcsine of t, and this is a trig derivative that you just need to have memorized. So this would be 1 over the square root of 1 minus t squared dt. And then notice here, the way that this is set up, let me grab a different color. We're looking at this compared to what we were given, and our u was this first piece, the arcsine of t, and that means the dv for us is going to be the dt part. So let me back that up a little bit. So we are given dv on this one is just 1 times dt. And that one I didn't pull out of nowhere, it's just can be kind of assumed that this is 1 times dt if there's nothing else there. Okay, so if we go backwards on that, our v for this would have to be t, because if I integrated t, I would get 1. Okay, now we can substitute what we know into this integration by parts piece. So I still have this big 1/2 in front. I'm going to use large brackets here. And then I'm going to, instead of having my integral of u dv, I'm going to use integration by parts and do uv minus the integral of v du. So this right here is what I'm trying to do. And for that, our uv would be, I'm going to put the v first, which is going to be t times the arcsine of t minus the integral of v du. So notice here my v is t times du is 1 over the square root of 1 minus t squared dt. And I'm going to close my bracket. Okay, that was my next big step, was the integration by parts step. Now we have this integral here to still deal with, and for this one, I'm going to do another round of u-substitution. So just for this piece, I'll just underline that in green. We're going to do another u substitution. And we don't have any u's, we have t, so I'm going to go ahead and use u this time. And I'm going to make that 1 minus t squared. When choosing where to do a u substitution, it's going to be the place that's inside a complicated function. So this is inside 1 over the square root. And then also notice here we have t squared, and out here we have t. And so you want to choose where the bigger degree is. So this is t squared. We want it to cancel out with this t. Okay. So next I'm going to take du, and the derivative of 1 minus t squared would be 2t dt. And then we're going to substitute those two things in where I have that green underline. So this first part I'm just rewriting and being very careful not to mess up when I do that. So I have 1/2 t times arcsine of t minus the integral of t times 1 over the square root of u times, and then this dt part, kind of like when we did u sub before, we need to get an equation for dt. So I'm going to divide by that 2t, so that would give me du over 2t. And I said an equation for du, I meant dt. Okay, so I'm going to substitute du over 2t right here, and then simplify from there. So again, I'm going to keep this first piece the same, so 1/2 times t times arcsine of t minus, I notice I made a mistake here. So right here, when I took the integral of 1 minus t squared, this should be a negative 2t. So let me move this over. This would be a negative 2t, so that would make this a negative 2t here, and this a negative 2t here. So sorry about that. Okay, so now notice here we have this negative 2 on the bottom. I can pull that out in front of my integral, and that would turn this into a plus 1/2 outside of my integral. I'm going to leave that t for now, or no, I'm not. I can see here that just like before, I have this t on top and t on bottom. Those cancel out. That will happen almost every time I'm doing a u sub similar to this. And then notice I have 1 over the square root of u. That's a little bit hard for me to wrap my head around when integrating, so I'm going to change this to u to the negative 1/2. Negative because it's in the denominator, 1/2 because it's a square root. And then now I just have du. Great. The next thing I'm going to do is integrate this part right here. Again, just rewriting that front piece, so 1/2 times t times arcsine of t plus 1/2 times the integral of u to the negative 1/2 would be, we're going to add 1 to the exponent, so u to the positive 1/2, and then you divide by your new exponent, so I divide by 1/2, and then close that bracket, plus a constant because we took the integral. Now I just need to clean this up. I'm going to do a couple of things. I'm going to substitute, let me grab what color I needed. I'm going to substitute t back in. I think I used orange. Yeah, way back at the beginning, we can see that t was equal to x squared. So I'm going to substitute t back in. I'm also going to substitute u in. And we just did that in green here. U was equal to 1 minus t squared. So I'm also going to substitute u is equal to 1 minus t squared back in. Okay. And then the other thing I'm going to do is notice here in the denominator, I have 2 times 1/2. And if I do, it's kind of like 1/2 divided by 1/2, and that will just cancel out. So that coefficient goes away. All right, so let's go ahead and do all of that. So I have 1/2 times x squared sine, oh, sorry, arcsine of x squared plus, and again, the 1/2 and the 1/2 cancel out. I'm going to change this back into a square root. 1 minus t squared instead of u, and close that, plus a constant. Okay, great. We are almost done. I'm going to, I have this t here that I'm going to substitute back in t equals x squared. When I do that, I have 1/2 times x squared arcsine of x squared plus the square root of 1 minus x squared squared plus c. Okay, and then for my last step, I'm going to distribute this 1/2 and then also do x squared squared, which would be x to the 4th. Okay, so the best answer on this would be 1/2 x squared arcsine of x squared plus 1/2 times the square root of 1 minus x to the 4th plus a constant. So this is perfectly, I mean, honestly, the step before would probably be fine. It'd probably be fine if you stopped here, but just in case your teacher wants you to simplify all the way, this would be more than fine. If you notice here, they both have the 1/2, so you could also write everything over 2. So x squared arcsine of x squared plus the square root of 1 minus x to the 4th all over 2 plus a constant would also work.